Welcome. I'm Tim Berglund with StarTree, and I see a number of you have already showed up. Really glad to have you here, whatever time of day it is for you. It's kind of early evening for me. I'm on the West Coast, so good afternoon, good evening, good morning, good middle of the night, or maybe you're watching this on recording. But in any case, very glad to have you here at this Apache Pinot meetup hosted by StarTree. We've got a pretty cool presentation today with a couple of folks from WebEx who are going to talk about things they're doing with Pinot there. While you wait here, I do want to run a poll. What work style is your company moving to? Hybrid, remote, full return to office, or unknown at this time? Or return to office, also known as employee retention mode. Go ahead, and I have answered.
Hey Tim, isn't this a real beauty of real-time analytics? I mean, it's like good to see all of this data coming in, streaming.
Exactly.
And that's a beauty.
It's not. It is. It's not exactly a problem at scale, but at least in terms of this survey. But it's real time, and I mean, these are aggregates being computed, so you cannot dispute that this is real time analytics.
Yeah, essentially, it is enabling a lot of magical experiences that we'll look forward WebEx to give to the customers.
Absolutely. The numbers I'm seeing here are kind of consistent with my expectation. Like, there aren't very many full return to office shops that I've heard of, but a lot of hybrid and a lot of remote, I think, is likely to be our future. All right, let me introduce our speaker so we can get started. So Sachin, who I've been talking to, is Senior Director of Engineering at Cisco WebEx, and he's leading an effort for WebEx data and analytics, focusing on, I mean, this is obviously an organization where they're going to have access to large amounts of data. So this is, a thing where he gets to solve problems at scale. But he's looking at figuring out ways to power customer experiences through data products. So taking data that exists, say, inside WebEx, inside that organization, and extracting value out of that data, pushing the value back to users of WebEx. So coming up with new and improved customer experiences based on what I would call real-time analytics. So kind of cool stuff, and obviously appropriate for a Pinot meetup. Vaibhav Mittal is a senior technical leader at Cisco, and he began his technical journey as an application developer, an early adopter of microservices and event-driven programming. But as you'll see, he has been able to more or less fully recover from that early experience and is able to lead a healthy and active life now. It's a joke, but I mean, right, being an early adopter of microservices was not a trivial thing. It's kind of a standard architectural style now. But man, 10 years ago, when people at conferences were first starting to use the word, it was rough. And that's not the story he has to tell tonight, but I know he has stories to tell about what that was like. And he's also moved through a lot of the kind of first generation big data technologies like HBase, newer things like Elasticsearch, MongoDB, and this prepares him well to think about customer-facing real-time analytics and, kind of pursuing that same mission as Sachin has in basically making WebEx a more useful product by exposing the state of the internal system through, a real-time analytics database like Pinot. So with that, gentlemen, I am going to mute myself and turn it over to you. And when you guys are done, I'll have a few more words for the meetup before we wrap up. So Sachin and Vaibhav, over to you.
Thanks, Tim, for the introduction. And I know it's your first StarTree meetup session as well. Thanks for introducing us, for a kind introduction. Hey, I just thought I'll take a couple of minutes to talk about WebEx collaboration and hybrid work before we jump into technical deep dive. Over the last 2 years, all of us have experienced how work has evolved, like how office work has evolved. We changed our working from 8 to 5, working in office, to working from home, and post-pandemic, now we have adopted hybrid work. This flexibility has been empowered by collaboration tools like Google Meet, Microsoft Teams, WebEx, and Zoom. All of my team right now is working remote for more than 2 years now. That's an incredible shift in our work style. We don't realize it every day. And WebEx has been in forefront enabling this shift along with others across its products. At WebEx, there are multiple products and businesses and a collaboration technology group which empower hybrid work. WebEx Meetings has anytime few 100,000 meetings going on every hour, generating max terabyte telemetry information per minute. WebEx has other products like cloud calling, contact center, device, which support meetings, callings, events, each generating huge telemetry and metrics data that need to be ingested, massaged, analyzed, presented to our internal and external users. During crucial COVID times, WebEx enabled enterprises, hospitals, educational institutes, governments to continue to operate. And now in post-pandemic world, it continues to empower hybrid work around the globe. WebEx data platform is run on 47 data centers across the globe. Over the last couple of years, there has been over $1 billion investment in AI at WebEx. Let's look at how WebEx data platform and analytics platform is supporting these increasing data needs of different WebEx workloads and products. WebEx data and analytics platform operates in FedRAMP, private cloud, public cloud, Department of Defense in IL5 environment. We are GDPR compliant. We are federated, which means for any US organization, a Japanese employee had a meeting with Australian client. The data is replicated and is made available in USDC. We have a lot of data variety that gets ingested into our platform, coming from different types of client telemetry as well as server telemetry and user and business data that we get ingested in. Client telemetry like media quality, video jitter, audio jitter, packet loss, system stats like memory, CPU, engagement data, where the usage data as well as the user satisfaction data is ingested into our data platform. Server telemetry, the media nodes, the different services nodes are generating huge media telemetry data and ingesting in our infrastructure. We have usage of different features being computed on the server side. Similarly, on the users, we have identifier information, their relationships, their organization information is all kept in our infrastructure. We have billing and usage data which get generated out of all the metrics that are getting generated. Just to give an idea about data volume and velocity that we have, almost 100 terabyte data gets generated every day. At any peak time, we have 300K messages per second hitting our Kafka servers. And not only we ingest this data, there is the more important beauty part of it, and where the magical experiences start getting created is what it empowers in terms of the end user analytics and different type of analytics that we generate. For a given end user, knowing how many meetings he attended, how many different people that he connected during the meeting, all of that data is available to the user at his fingertips. Similarly, an IT admin would want to know the usage and utilization analytics and slice and dice in a different dimensions on an ongoing basis. They want to look at the troubleshooting data, which includes the ongoing meetings that are happening. And in ongoing meetings, how can I troubleshoot these meetings? Can I know more about quality for these meetings and the events that are happening on an ongoing basis? We also generate business intelligence data, customer analysis, customer churn analysis, and all of this data is also fed back to our partners, which are service provider partners, if they are managing those customers. We give all of this data back using APIs as well. And when we operate all this platform, there are some few core principles we operate on. One of the first principle is we want to make sure that we have real-time analytics. And this has been from the day one, we wanted to make sure that we are ingesting the data and being able to retrieve the data with a P99 of lesser than 5 seconds. We have a lot of technology we have accumulated over a period of time. We have Hadoop, we have Kudu, and the focus that we have is to make sure that when we adopt new technologies, we want to simplify and consolidate tech stack. When we are looking at new technologies, always keep this in mind. The third and the more important principle that we have is when we are as a data platform, we want to enable the data products ecosystem for our consumers. So they should be able to build data products easily with the data platform that we have. While all of this, we are making sure that we are a frugal engineering team, always focused on making sure that our software costs and hardware costs are consistently reducing. And last but not least is self-service. We want to make it easy for our internal people to build analytics dashboards, as well as the external people. Now, what we were seeing was actually also getting reflected in what the trends we were seeing externally as well. Earlier, the customers we were generating dashboards and reports for the customers once in a day or once in a week. And the customers the IT admins were fine with it. They were looking at the usage analytics. They were saying that this looks good to us, and they were happy with it. A few times we used to get queries about, we want more data about certain day, or we want more data about certain geo. And our analysts and operators used to generate those data using Hive queries and send it back to the customer. That was a good cadence and good things going on with the WebEx. What we saw during the pandemic is we started seeing customer IT admins asking us, how many meetings are happening per geo? Now everything suddenly changed. They started asking, how many external users are joining this meeting? How many user-facing meeting, or how many meetings are having bad quality? What operating systems they are using? So there are multiple dimensions on which they were interested in starting to ask us questions. And we had an option to aggregate, which was not very cost effective in terms of storage, compute. So we were thinking about what technology we need to start looking at. And that's the time we started doing some POCs where Webber can give more insights about the POCs we did and what kind of technology evaluation we did. Over to you, Webber.
Thanks, Sachin. So the big question that Sachin just referred to, that was in front of us, whether to pre-aggregate and not to pre-aggregate. So before I actually go into that question, I'll just give a view of the data that was under consideration. So the WebEx client, be it whether you're joining through the browser or through the app or any OS, is uploading a lot of telemetry data. The same kind of data, which is media quality data, is coming from the server, and we collate the two data in order to determine the user experience. Now, this data needs to be sent pretty frequently since we do not want to miss a blip and enter into a larger problem going ahead, where some of the media servers could be not working correctly, some of the regional servers could not be working correctly. So the frequency at which this data is uploaded is pretty high. So we kind of end up into a 1 billion plus events a day. On the dimension aspects, we have 150 plus dimensions that this data needs to be analyzed for us to even make a good assessment of what the user experience is. So the dimensions are really high when it comes to end user query. The data that we are actually considering to present to the end user is already being used by our internal SRE folks or our developers to figure out how their services are doing in production. So this data was already being uploaded, massively stored in Elasticsearch. It was terabytes worth of data across 60 of the Elasticsearch nodes. And to be frugal, what we were doing was we were regularly rolling up this data. So on a weekly basis, on a monthly basis, to a more post-time-grained window. And we were moving them from a SSD-based disk to HDD-based disk, so that, data loses its value over time. So that is why we were kind of moving this to a cheaper storage so that it was not frequently queried. So, and what many of the teams were even doing to analyze this data, it was a combination of pre-aggregates and raw queries over Elastic. So they were putting up their own Kibana dashboards. And some of the teams that required really a faster querying were pulling data out by their custom Python jobs and putting in their own stores like Snowflake, etc., so that they could actually analyze it faster and just the data that they required. Now the game changed. As Sachin said, we had a whole new set of questions with the pandemic coming in. And so we were presented with two choices: whether to take the blue pill of the pre-aggregate syndrome, where we spend a lot of compute, we spend a lot of storage for 90% of the data that will never be queried. Or we take the red pill, wherein we embark a journey of runtime aggregations, and we find a store that will suit such kind of query. So we took the red pill, and we shortlisted 3 candidates for our POCs: Elasticsearch, ClickHouse, and Pinot. So all these 3 stores, they were evaluated on 3 basic criteria. The first being the query performance, the second being the effectiveness of operations and the ecosystem that were there around these stores, and the third were the frugality aspect, whether they supported rollup, whether they supported tier storage. As you said, as you see, we are already using that in Elasticsearch. So we wanted to continue those practices even for the newer store that we picked. And if Elastic was big, good enough. We were already doing that. So coming to the first criteria that we had, and possibly one of the most important criteria, was the query performance. So the hardware setup for the queries was 16 vCPU machines, 64 gig of RAM on all these machines, 2 TB SSD disks. For Elasticsearch, since we were already storing data there, we did not disturb the setup. The 60 node setup was taken as it is. For ClickHouse, it was 36 nodes. And for Pinot, it was 36 nodes with 3 brokers and controllers. The data in consideration was 1 month worth of media data, which is roughly around 30 billion rows in that particular table. For Elasticsearch, what we did, there was just minor tweaks that we did. So doc values were already enabled. So you could, as Sachin said, people were running Hive queries to answer customer queries, or they were doing on the fly. So that was pretty good with the doc values. But we converted them to the inverted indexes so that they could be faster and it could be a fairer comparison with the other 2 databases. ClickHouse, we were using a mix of min-max and sect indexes. On Pinot, there were a mix of range and inverted indexes. We were not using any sort of materialization, so no materialized views in ClickHouse or no start tree indexes in Pinot. We just wanted raw capability comparisons here. So while picking the queries for evaluation, we had 2 principles in mind. Both internal and external customers should be served with the same data set. So you should not be doing processing for separate processing for an SRE engineer that is viewing the data, or for the end user admin who's viewing the data. And if I extend this example further, tomorrow this data can be made available to partners, to retailers, to distributors. So you should not be doing a lot of different things for a lot of these customer personas or user personas. They should be served out of the same data set. So that was the first thing that we were looking at while picking the queries. The second was, obviously, we wanted the answers to the new questions, and we wanted it at a P99 latency of less than 5 seconds. So the first category of queries that we picked were targeted towards our internal consumers, that how am I doing in terms of my audio or video quality across the board, and where do I need to pay attention? Are there any red flags? The second, I mean, you may just argue that it is a predicate. Why do you care? It's yet another predicate. But the amount of data that comes into the query is drastically reduced when you have an OR filter. And we have a reason why we kept it there, because later in the game, we started basically experimenting with the partitioning feature that Pinot provides and which ClickHouse provides. And we just wanted to know how the stores were doing when the load was reduced versus when the load was pretty high and it had to do a kind of a table scan. The next 2 categories of queries that we picked were more towards the end user analytics query on what our users wanted answers for. So typically the use cases that we were getting where the user said that many of our people are suddenly facing performance issues or are having laggy meetings. And one of the top things that we found out was they were joining the meetings using the browser instead of the app. And that is why they were not getting all the goodies that the app had to provide. So this was a report that we provided, and now that is actually visible even on our analytical dashboard. And users can now run education campaigns to see, okay, go ahead and use this feature. You'll have a better meeting experience or a better calling experience. So the next two categories were for that. P99 analysis, which is the fifth category of the queries that we put, forms an important aspect of our whole analytics that we perform, since it gives a population view of things. So how am I doing? What is my P99 for a region? Or what is my P99 for a browser versus my WebEx app and WebEx app on an OS? So right from even Cisco's point of view, where I need to be spending my more time and energy, to a customer point of view, that how is his meetings going on in a region versus US versus Europe versus Asia. The last was, during the pandemic, we actually released more than 800 to 1,000 plus features. And it was designed towards what is the adoption. The noise reduction levels, we were innovating a lot in that area. Then we had breakout rooms that were implemented. So what is the feature adoption? And this again was important both from Cisco's point of view and our customers and partners, that how effectively WebEx is being used. So for example, you're in a planning meeting, use breakout rooms. The team can do planning and then come back again. So all these were really important questions that we required answers for, both at Cisco and a customer and partner level. So to the results. So I'm not going to go into details of each and every number, as we'll be doing a blog post soon where we'll go into those details. So some of the highlights, though, on the numbers was distinct count was really bad across the board for Pinot, ClickHouse, or Elasticsearch. The thing to note here was we were not using the approximate version, so the Hyperlog log or the Theta Sketch versions of distinct count. As soon as we use that, this is milliseconds. This is not the 10-second numbers that you see here. But while performing the analysis, these were raw counts that we were dealing with. So both Pinot and ClickHouse, they support the approximation techniques. For the other category, what we observed was Pinot is kind of maintaining its P99 as the concurrency grows. And in some of the categories, it is actually 4x faster than ClickHouse. For percentile, ClickHouse is faster, but the performance for Pinot was acceptable. So once we saw the raw numbers, what we decided was Elasticsearch no longer should be considered for our further analysis, and we concentrated on ClickHouse and Pinot. So just a comparison of the latency at P99 for both of these. So if you can summarize, 3 out of the 6 categories, Pinot is 4x faster. For others, it is comparable. It's not, wherever ClickHouse is faster, it's not by a margin of even 2. On the effect of concurrency on these systems, as you can see, for Pinot, it's low linear and it plateaus out at a certain instance. For ClickHouse, it's steep linear in certain categories. So for example, when the whole data was getting scanned, so the blue is when the SRE use case that I took, where the entire table would be scanned, you can see it's going to the roof there. On storage, for the entire media quality data of 30 billion rows, Elasticsearch was taking 87 terabytes, whereas Pinot and ClickHouse were 8 and 6 terabyte each. Now, this was understandable since Elasticsearch was spending most of its storage storing the keys and not the values, because it's a kind of a doc store. So keys take up space. Again, thing to note here was we were not using best compression. It was just partial compression that we're using in Elastic. Numbers for ClickHouse and Pinot are explanatory because ClickHouse is using LZ4, whereas Pinot is using more of directory encoding. That is why the difference there. So just to summarize, Pinot was 4x faster in ClickHouse in most of the categories except for percentiles, and distinct count both were performing equally bad. Latency effect for concurrency. So Pinot was low linear and ClickHouse was steep linear. Pinot actually supports a higher throughput than ClickHouse. So in our tests, Pinot was supporting around 71 queries per second, whereas ClickHouse was around 50 queries per second. And Elasticsearch was not even, going ahead, considering for our use cases, the storage cost was prohibitive, the SLAs were not met. So Elasticsearch was something that we decided was not good enough for the use case that we were using it for. That said, it's still a great store, for searches, possibly one of the best for that, but not good enough for real-time use cases that we were considering. Okay, the other evaluation criteria, the ease of operations and the ecosystem. So the initial cluster setup, we believe Pinot had multiple components. You had the brokers, you had the servers, you had the zookeeper, you had the minions. So it has 4 or 5 components that needs to be deployed. So the initial cluster setup is a bit tough in Pinot as compared to ClickHouse, which has a single component. Zookeeper is still optional there. Though they are actually shifting their application and other stuff to be Zookeeper based, it's still optional. So it was easy to set up ClickHouse, and it's easy to set up Elasticsearch as well because they just have the master node and the data node, and they do the gossip protocol. But more important to us than the initial cluster setup was the cluster management aspect. So how do I add a server to the existing cluster? How does the cluster behave when one of the server goes down? And that is where Elasticsearch and Pinot both are really easy. It's very easy to add a server to an ongoing cluster. You just add tags, and for segment and sharding rebalancing, things are taken care of. Even though the segmenting is, you can configure how to actually assign your segments to these new servers. The default strategy being balanced. It takes care that it's a fair play and all segments are distributed fairly amongst all the server, even the new server that you add. For ClickHouse, we felt that it was a lot of configuration that you had to do manually. So go ahead, create the table on all of the ClickHouse servers that you add, manually go ahead and modify the config files. So we could develop an ecosystem around this and automate all this in ClickHouse. But what we were looking for is the support that we got from the native store and the ecosystem itself. Another really important feature was multi-tenancy. So here what we were considering is we have a lot of workloads that are running. So Sachin introduced the business as he started presenting. We have calling, we have meeting, we have contact centers. We have our internal customers that are coming on board. Now we want to avoid a noisy neighbor sort of a problem that comes up. So some of our calling businesses are really critical in terms of they have call queues. So contact center jobs are powered by WebEx calling, and you have call queues. Now suddenly, let's say there is an OH patch released or there's a new product that is released which has some glitches. Your contact center call volume increases, and suddenly you're looking at a noisy neighbor. It should not impact our other businesses. So Pinot has this really good facility of tenancy wherein you can actually dedicate servers and brokers to a particular tenant, whereas the cluster remains the same. So you don't have to spin up another cluster for to avoid a noisy neighbor problem. And another benefit that you actually get is the example that I took where there is a certain spike in one of your workloads. You can just go ahead, change server tags and do a couple of REST calls. And you can suddenly now have more machines or more images that are powering your spiked up load. So from internal brokers, we can just ship them to a calling broker, and you get the performance gains without doing much. This sort of feature was not supported in ClickHouse or Elastic both. The cost to serve queries remains moderate for Pinot and ClickHouse. Elasticsearch, it's really high. Sometimes our CPU is spiking up to 90 and 99%. So it's really high on Elastic to serve queries. Coming to the core capabilities aspect of it, as when I was covering the data under consideration, if you would have seen rollup and tiered storage are something that we are using a lot to be frugal. So we were looking for an equivalent support in both ClickHouse and Pinot. So Pinot via Minion has this merge rollup task, which is really, really flexible. So you can say that after a week, make my data more coarse trained. So instead of possibly a minute or hourly data, make it a daily data. After a month, make it a weekly data. After a year, make it monthly data. So all that is possible in Pinot just by configuring the Minion task appropriately. And you can actually choose to move the data from SSD backed server to an HTTP backed server. So that is something that we thought is it's partially available in ClickHouse, but the support is really limited there. Last but not the least, and possibly one of the most important aspects us was the in-house extensibility. I mean, Elasticsearch has been there for a while, but ClickHouse and Pinot have started picking up in the last, I mean, as real-time OLAP is picking up in the last 5 years and Pinot in the last 3 years. So we did not want to run blind in these stores. We wanted to go ahead, see how the code was performing, what were certain design discussions, decisions that were taken, can we extend it? Because not all use cases might be covered. They are still in their growth phase, the databases. They are not in the matured phase as something like what Oracle or SQL Server would be. So that was a really important aspect. And we are a team which has a primary skill set in Java and Go. C++ was not our strong suit. So that is why we decided to pick Pinot. So that we could actually go into code, not run blind, see what's happening, and we can extend for features that we use a lot. So we picked Pinot, and we are actually shifting a lot of our workloads to Pinot. And as more and more teams come in, so what used to happen really with the operation folks before we switched to Pinot, they had their dashboards and everything built on Elasticsearch, and they used to just go and log in into Kibana. And then they used to take a coffee break or a bio break. So, and when they would come back, they would have some of the panels getting loaded. But as we switch to Pinot, this has gone down. So their dashboards are just 30 seconds away. Just covering where we are at WebEx in terms of Pinot. So right now our production clusters are 100 plus server nodes or data nodes. We have deployed it, as Sachin was saying, in most of our data centers, which are federated. So EU has its own cluster, APAC has its own cluster, Canada has its own cluster. So wherever the data residency laws, they warrant us to have a cluster, we have a Pinot cluster there. Now, all these are actually, the orchestration is maintained by something called as Portainer. So we are using that for easily patching up all our servers or our Pinot images as a new release comes, or if we have to do OS level patching, etc. So we are doing it via Portainer. Now to the enhancements that we've made to Pinot over a period of time. Are in the following areas. Partitioning. So partitioning is really important to us, and I believe it's more to do with how a company is growing, and most of the big companies actually grow in that manner is through acquisitions. So you go ahead and acquire many products which are kind of doing a similar job. So even though you have to maintain individuality within the company for these teams, for the end user, they need to look at one product. So we were faced with a similar issue wherein we had 3 or 4 of our point products doing the same job. So on the UI, they had to look as one that, okay, this is your audio quality, this is your video quality, but they had their own release cycles. They had their own way of backfilling data. So let's say a schema evolution took place. and the customers wanted 2 years back of data to be available to them. So each of them had their own release cycle, their own way in which they backfilled. So what we did was we used the partitioning feature that Pinot has. So Pinot by default provides, murmur and hash code and these partitioning functions. They are not predictable in the sense that a hash code for two of our enums could be the same. So what we really wanted was each of the point products have their own segments, and none of the data actually goes cross segment. So we implemented a new partitioner in Pinot, which is the bounded column value partitioner. This is actually a part of the .10 release of Pinot. So by this, you can actually predictably send your data into separate partitions for separate point products. They don't collide with each other anymore. They can go ahead and backfill change their algorithms independently without overlapping each other. So this was a big support, and the design was flexible enough for us to contribute this back. That said, we have picked an unnatural partition, which is point products, a more natural partition so that most of the data is skipped and your end user queries can perform really better, is an organization partition or a partner partition. Now, Pinot till now only supports a single column partitioning support. So what we did was we extended it to be for multiple partitions. So the building blocks were already there in code. It was just about enabling them. It took just around 3 to 4 days for us to actually implement multiple column-based partitioning in Pinot. So this is merged into master, should be available with the next Pinot release. Now, on the visualization aspects, Pinot has a really good integration with Superset. But most of our internal consumers were making a shift from Grafana and Kibana. So we did not want to kind of break their experience, and Grafana is really good at what it does. Kibana is really good at what it does. So these are the plugins that we are working in-house, and we actually intend to open source them at sometimes in the coming months. So we are working on a Grafana-based plugin for Pinot, wherein you can visualize all those data. You can configure the alerting as what Grafana allows you. So work for this is almost done. There are things that are specific to Cisco right now in there. We are trying to make it more generic, and we'll start discussing this shortly with the community on how we can open source this. Now, on the productivity aspects, rollups is something you must have seen is pretty important to us, right? So Pinot, again, as I had covered via the merge rollup task, has a fantastic support for rollups. So we are making enhancements on that aspect as well, wherein right now you have a single column, single aggregation support for rollups. What we are doing is a single column, multiple aggregation support. So within the merge rollup task, what you would now be able to do is specify a column, have multiple aggregation functions like sum, min, max, and they will be computed as a part of the same run in Minion. You don't have to parse the data again and again. So that would actually speed up your Minion processing. And we are adding the percentile support for these rollups. Pinot is fully integrated to our data cataloging and governance system now. Now, this is something we cannot open source, obviously, but it's just a very important part of productivity suite that is there. So it's fully integrated into our governance system. So it follows all the privacy concerns that other components within WebEx does. So that is where we are currently with the Pinot infrastructure. We are trying to onboard more and more of our consumers on the Pinot. So that's it for the technical aspects. The team is hiring. You can actually reach out to us at webex.com careers. This is publicly available, and we would be happy to have people on board and contribute to the Pinot open source. With that, I'll just open it up for any Q&As that are there. Okay. Why and how are you using Minions? Okay, so for us, we are using Minion pretty heavily. One is obviously the real time to the offline flows. So that is where we are using Minion. The other is we are using Minion for the rollups. So within the offline tables, how we can perform rollups. The third use case that we are looking at, and that's really under development right now, is using Minion for GDPR and data retention policies. So we have a bit of a complex requirements that come, and especially, I mean, since meeting data is sensitive, even title of a meeting can be sensitive. It can actually go ahead and reveal a lot of stuff about what the execs are doing. So many of our consumers, they are really cognizant of that fact, and they want the data to be deleted upfront. So that is something that we are planning to build into Minion. Is there going to be a YouTube recording? So I believe yes, there is.
Yeah, let me take that one. 100% yes. This is being recorded. It'll be on YouTube, and we'll tweet it. If you follow @StarTreeData, I'm TL Berglund on Twitter. I'll tweet it. Also, if you sign up for this will sound like a StarTree commercial. I'm just saying the way you find out about this, go to StarTree.ai. If you sign up for the newsletter, there'll be a link in the newsletter as well. I mean, we're recording it. We'll push it out. So those kind of StarTree like channels are places you'll be able to find it later.
Thanks, Rick. So does Pinot provide HA? How is WebEx handling it? So yes, Pinot does provide HA. So there are a couple of aspects that you can do. You can actually configure a replication factor for each segment, and Pinot will try and rebalance it. Now there are actually a lot of segment assignment configurations that you can do there. But let's not go into that. But yeah, the short answer is Pinot does provide HA, and you can specify a replication factor. At WebEx, we are using that support pretty heavily. Why didn't you enable start indexing during evaluation? Okay, so we wanted to be, I mean, kind of fair. So we could have gone the start tree route and the flexible, I mean, the materialized view on the ClickHouse end. But we wanted raw performances, what were there. In the production, we have enabled start tree for some of our workloads. How do infrastructure costs compare between Pinot and ClickHouse and Elastic? Okay, so the main difference between Pinot and ClickHouse in terms of infrastructure cost is, I'll just say it's storage, and ClickHouse has a lot low components to deploy. But I think all that is negated. I mean, when you look at the query performance that it provides and the kind of operational, the ease of operations that are there in Pinot. Yeah, the only real benefit I saw on the ClickHouse was it has a better compression. Elastic.
From an operation perspective, I think Vaibhav, you covered as well. Operations perspective, we have significantly benefited from having Pinot compared to ClickHouse. Right. So that was an analysis. I think you can look at the analysis in details.
Yeah. So does Pinot support ingestion of data from Kafka? Does it have a transport? Yes, it does. So Pinot has the concept of real-time and offline. So real-time tables can be ingested via Kafka or Kinesis, whatsoever your streaming platform is. Offline is, so it's a kind of a Lambda architecture that Pinot has. And offline, you can read your data from HDFS or S3 and then just upload it via SparkChub. So short answer, yes, Kafka is supported ingestion via Kafka. Are all the features that the team built for Pinot now available on open source? Two of the features are, one is already released as a part of the .10 release that happened, I think a month back. One of them will possibly be released as the .11 release or whatever the next release for Pinot would be. The ones that you saw in yellow are under development, and we would be open sourcing in the coming months. Are there ways to hide PII data during some filtering automatically? I believe someone from StarTree can possibly answer that question better. But what we are doing at WebEx is we are handling it at the ingestion layer and the query layer. So the PII data is obfuscated while it's making to the source. And Pinot, to be honest, is more of an analytical store. So we avoid storing a lot of PII data in Pinot. How did you push your month's way of data on each system? Okay. So Elasticsearch, I know it's hard. I mean, bulk indexes, you have data loss issues, etc. So for that, the good thing for us was it was already there in Elasticsearch, so we did not have to go through that pain. For Pinot, we actually used the offline tables capabilities. So any of our data is actually backed up in our data lake as well. So we read the data from the data lake via offline jobs, and we uploaded them to Pinot. Okay, so Pinot for us is deployed using Portainer. So Portainer is an orchestration platform which can be used with K8 or raw Docker Swarm or Docker Env. So we are using Portainer for that. It's not; these are not bare metal servers. So these are we have an internal OpenStack infrastructure that hosts our machines. So it's based on an OpenStack infrastructure hosted in the WebExTC. How are joins performed in Pinot? Okay. So we do them using Pinot. They were not natively supported in Pinot. There is something called as lookup functions that comes close to joining. But I believe there is, I mean, there was a post, I think just a week back that joins are coming into Pinot. So you should stay tuned for that. And
Yeah,
possibly,
there's a branch where people can play with an early version of the shuffle join, and then we'll be soon merging it into master, and then keep optimizing that.
okay, good. Part of the talk, yeah, so that's the plan to have a blog post around this so that others can refer to it at a later stage. Other than, okay, so how I'll put it is all subjective in terms of what works for you and what does not. For operations in ClickHouse, apart from the easy start, we felt that it was tough for us to maintain a ClickHouse cluster than it was to maintain Pinot, and especially when you add servers, how the cluster behaves in terms of rebalancing of segments and fairness of segment assignment. That was really good in Pinot. Okay, so I believe we've covered most of the questions. So let me just. How confident are you that are you prepared for a wave of?
You'd better be.
Yeah, so how I'll put it is we are happy to learn if we have gone wrong somewhere in ClickHouse, but we are pretty confident that the analysis that you did was pretty exhaustive.
And I think if I could comment on that, a key point is like, I mean, I work for a database vendor. And so anytime a database vendor publishes performance benchmarks, you know, nobody lies about those. Okay. That's just crazy behavior. So people don't trust benchmarks. Every vendor who publishes benchmarks has taken actual measurements, right? It's just that they're measurements that the vendor contrives to feature their strong points and all that kind of thing. That's not what you're doing. You're not a database vendor. You run a conferencing service. And so you're taking measurements of how these things are performing in the context of an actual application. So anytime anybody ever asks me about benchmarks, I make this point, which is that you should take measurements in the context of your actual system because that's where they're meaningful. So it would be hard. And obviously you can have things mistuned and this, that, and the other thing, and you should have done the dance and it would have worked better. Like anybody can make a criticism, but it's difficult to criticize that these are the results that you got in a practical application that's doing a thing. And the thing that it's doing is not just measuring the database, you know. So this is the way benchmarks should be done, I guess is what I'm saying. So hopefully it won't be too much hate mail.
Hopefully not. And exactly as you said, Tim, we are not in a database vendor world. We are application builders, and we want to leverage the technologies for right usage.
You want things that work. So it's that there is a certain credibility that comes with that. All right. Well, hey, Sachin and Vaibhav, that was amazing. Thank you very much. This was great. That was one of the comments that, wow, this was great. Yes, it will be available on YouTube. It should be on the StarTree YouTube channel, and we'll publish it to the world, push it out in various ways. I'm sure all of us folks at StarTree will be tweeting about it, posting it on LinkedIn, so it should be difficult to avoid once it's available. Could you go to the next slide?
Yep.
Yeah. Okay. So, a word from our sponsor. If you'd like a demo environment, there's that start a free trial link there. This is just startree.ai. This is the StarTree website. It's the colors didn't work on that URL, but you see that right there. Startree.ai. Go there, and you can click on start a free trial and get a demo environment to play with. Also, next slide, the Real-Time Analytics Summit, August 16th and 17th, 2022, San Francisco, in person. RTAsummit.com. That URL is down at the lower, that's the lower right. So you want to visit there, you can get details on how to register. The call for papers is still open until Monday, end of day Monday Pacific time. So you can even still put a proposal in to speak if you'd like. If you've got something to talk about that you've done with Pinot, or something even related to Pinot, or related to real-time analytics in general. It doesn't need to be just Pinot things. Love for you to give us a proposal. And otherwise, everybody at this meetup, if you've been here, if you're watching this recording between now and the beginning of August, this is something relevant to your interests. So I'd love to see you there. Those are the keynotes we got signed up for. I'm not sure about that guy on the right. You want to watch out for him. But Zhamak, Kishore, and Jay are definitely thought leaders in the space and people worth listening to. So check out the Real-Time Analytics Summit. Love to see you all there. And Vaibhav and Sachin, I think that's it. So I want to say thank you again for being here. Anything else before we wrap up?
No, it was a great pleasure talking to you, as well as explaining what we did.
Yep, it was awesome. Thank you. And I see all the clapping emojis happening over on the left. Whoever's doing those, thank you. All right. Everybody have a great night, or whatever time of day it is for you. Thanks for being with us.